In this video, we're going to be going over 3 questions on the impulse momentum theorem to really test our understanding of theory. While this unit is quite calculation heavy, having a knowledge of theory is still really important in understanding what you're doing and why you're doing it, and it's also essential in being able to solve more complex problems down the road. So to get started, we have a question that reads, you roll a bowling ball into a pillow, which brings it to a complete stop. Then, at the same velocity, you roll it into a spring, causing it to bounce back with equal and opposite momentum. Among the spring and pillow, which object exerts a greater impulse on the ball? So to start off, we're going to make a quick diagram of the situation. We have our pillow and we have our ball that's approaching the pillow with some initial velocity. Next, we're going to use our formula for impulse, particularly m delta v, as a guide to our thinking. So expanding this out, we get impulse is equal to mass times velocity final minus velocity initial. So we don't know what the mass of the ball is, and we don't know what the initial velocity of the ball is, but we do know the final velocity of the ball is equal to 0 meters per second because the question says it comes to a complete stop. So this simplifies our formula for impulse to negative m times vi. So although we have not calculated a numerical value for impulse, we do have a simplified expression for it, which can still be used to compare the relative impulses that the two objects impart. So for our second scenario, there is our sketch of what's going on. We have a ball that is approaching the spring at some initial velocity. The question tells us that the ball rebounds with equal and opposite momentum. And because mass stays the same, that means it rebounds with equal and opposite velocity. So velocity final, or Vf, is equal to negative Vi. So now we're going to repeat the same procedure that we did in the first scenario. We're going to write out our formula for impulse as m delta v. We're going to expand it out, and then we're going to substitute in what we know. We know Vf is equal to negative Vi, so impulse is equal to mass times negative Vi minus Vi. This simplifies to impulse equals negative 2 times negative 2m times Vi. Comparing our expressions for impulse, we can observe that the impulse imparted by the spring is double that of the pillow. The reason being that the spring causes a greater change in velocity of the ball. So question number 2 asks us to mark the place on the ticker tape timer where the car begins to experience an impulse. So first off, if you don't know how ticker tape timers work, I'll provide a brief explanation. Basically, they are connected to the object whose motion they will track. At fixed intervals of time, they create a mark or dot on the paper, for example, every 0.1 seconds. 2 dots on the paper would then mean 0.2 seconds have elapsed. If an object travels at a constant velocity, it follows that the distance between dots will stay constant as well. However, if the car is accelerating, then the distance between 2 dots changes. So the question tasks us with locating the place that the car begins to experience an impulse. Well, we know impulse is equal to F delta t. So when the car experiences an impulse, a force must be applied to it for a certain period of time. And according to Newton's second law, force is equal to mass times acceleration. So where the car begins to experience an impulse, it will also begin to accelerate. So looking to our ticker tape, we know acceleration occurs when the distance between dots begins to change. So for this particular ticker tape, that looks to be around the 6th or 7th dot. So that is where the car begins to experience an impulse, and it experiences the impulse for the duration of the ticker tape. So question number 3 asks us, which takes more force to catch in the same amount of time, a bowling ball or a ping pong ball, assuming velocities are the same? So to answer this question, we start off with our formula for impulse momentum theorem, or our statement for impulse momentum theorem. Ft is equal to m delta v. Looking at the right side of the equation, we know that the mass of the bowling ball is greater than that of the ping pong ball. Delta v is the same because the question tells us that the velocities are the same. An increase in the right side of the equation results in an increase in the left side of the equation. The left side of the equation consists of two variables, force and time. Since we are told that the time taken to stop the ping pong ball and the bowling ball are the same, it is the force that must increase. So our answer to this question is A. The bowling ball takes more force to catch in the same amount of time because it has more momentum as it has a greater mass. So that brings us to the end of this video. Thanks for watching, and I hope you were able to strengthen your theoretical and conceptual understanding of the impulse momentum theorem. As an additional resource, I would highly recommend checking out the egg drop simulation on the Physics Classroom website, which details how factors such as size of the egg, height from which it is dropped, and material of the landing surface impact the force that the egg experiences upon landing and thus its overall safety. I'll provide a link for that in the description below. Have a nice day.